Today we discuss software architecture as part of systems development. Most of the systems do have a lot of elements as software, and that's where the significance of software is growing. And software architecture plays a significant role in the success of these systems. We will go through the context, process, principles, reference architectures, and summarize the perspectives on software architecture. Our goal here is to try to understand software architecture as a process defined by some of the experts and as well as a synthesis to try to evolve it better and try to make the best use of practices and approaches together to get the best of it. So let us look at software architecture and design as a practice. So when we look at it, the software architect role, whoever plays it, kind of stays between problem space and solution space and bridges the gap between the requirement analysis and software design and performs the architecture definition process. So, like we see, it's a journey from the drivers and goals of the system, understanding the business principle, the rationales, and the implications, and capturing the technical principles behind it, their rationale and implications, thus arriving at architecture decisions which would enable us to create systems, thus delighting the end user and also the other stakeholders of the system. So, if you look at it from a high level perspective, it is about defining the context and scope of the software system and division of these into subsystems and packages, which is highly defined as first steps. Then division of these into classes. Typically, if you are looking at it from an object orientation standpoint, it's about classes, but some kind of packaging or subsystem organization, you can look at it with whether it is functional programming or object oriented, and then division into data and routines within the classes, and then defining the internal routines, thus leading to construction. This obviously, as traditionally, has been following a waterfall approach like architecture first, then detailed design next, and construction. But this is evolving now with the agile practices coming to the picture. So when we look at it in more detail, this diagram has been adapted from Software Systems Architecture, the book written by Ian Woods and Nick Rosansky. So here, like you see here, initially it is about defining the scope and content context, which is clearly understandable and um, with discussions with stakeholders and then capturing the first cut concerns. So, and then we go into the process of defining the architecture, building a skeleton, and continuously evolving the architecture concerns, creating the and experimenting with the skeleton, and based on that, trying to discuss further with stakeholders and arriving in that architecture description. Of the first three steps, when we look at it, it is more about identifying the goals and objectives through architecture workshops and several other capturing methods like attribute driven design kind of methodologies or ATAM methods where you kind of capture more details into the requirements and understand what are the key non-functional requirements and the risky functional ones which we have to experiment with much more and which is probably the first to go. So this kind of set of things can be seen as the first set of architecture principles or guidelines for the specific system that we can look at. So these are the kind of rules for the system to evolve. Then we look at the process. Step 2. It's more about defining the architecture by creating skeleton. So the objective is to kind of look at architecture patterns, domain driven design, which allows us to break down elements in a domain perspective, then arriving at design patterns and delivering source code so that we can create the skeleton and try to verify the risky non-functional requirements and the risky non-functional as well as the functional requirements, and get uh, measure the measure or evaluate the architecture to a certain extent to go for to the next step. So this is where it becomes a kind of simulation using the skeleton system, which also plays a very important role in defining the architecture and taking it forward. So when we look at it, whether it is really a step-by-step approach, maybe not exactly, because if we are into the practice of architecture, we are quite used to these methods. So it's more about an approach where we try to define high-level architecture patterns, like say we identify layered and microservices as a basic approach that we go ahead, and then we also look at the breakdown of subsystems. For example, in the case of an online retail store, it could be about product catalog, ordering, shipping, basket, security as subsystems. So then we go about iterating on this and trying to define the service elements, the front end elements like shipping, service, and then the according front end elements. Then we also go about looking at kind of trying to map it with the technologies and then arriving at a skeleton. So here we try to identify a first part, first set of functionality or features, part of say like product catalog, RESTful service, and authentication or security related services, so that we can create using a front end using Angular JS. We can authenticate into the system and get to see the product catalog, which is a service using Python Flask, SQL Alchemy, and Postgres. So this is one example of typically how do we look at it, and then we continuously iterate to improve this and try to refine the skeleton as well as the overall picture in terms of how far we have achieved or we are satisfying the goals and the system objectives. So this is very important, and we kind of go to the stakeholders with this understanding. So this is again, like Stephen Confoy once mentioned, it's about start with the end in mind. So achieving the goals and system objectives being the end that we have, our objective is to continuously iterate to be able to satisfy with those goals and objectives. So what let us look at what principles help us to model it better. What are all the key directions which we need to take? So one of the principles about system modeling, it's about you whether we look at it from an object orientation standpoint or functional standpoint, the structure, the interactions, the behavioral aspects of it, from an internal and external aspects, all plays an important role in the system modeling. So this influences in creating the structures and also how these elements interact between them. And typically, when we are looking at object-oriented analysis and design, we used to use the methods like uh, nouns as objects, from the requirement specification. If we find nouns or the use cases, nouns as objects, verbs as methods related to the object, as a way to identify the objects and the classes structures. And then we used to also apply general responsibility assignment patterns, often called grasp patterns, to organize the responsibilities of these objects in the system. So these are the some set of principles, while we also highly look at the solid principles, which is like single responsibility, open or closed, list code substitution, interface segregation, dependency inversion, kind of more from an object-oriented angle. And today we more probably look at ideals principles like interface segregation, deployability, event-driven, availability or consistency, loose coupling, single response, as more in the direction of distributed systems and evolving architectures. So when we are looking further into the details of these contemporary principles, we will obviously come across the reactive manifesto, which talks about the major directions in terms of responsiveness, being resilient, being elastic, and message driven are the as fundamental principles of these distributed reactive type systems, which represent most of the systems we are seeing in a digital environment today. And then we also try to look at it from different platforms and how do we organize it as using different technologies across different programming languages. So it's a matter of what we are trying to achieve. So for instance, if you have an IoT system, you might even have a C++ based approach for an embedded system, which could finally translate it into a RESTful service and provide a RESTful environment. And if you have a machine learning or analytics platform, we probably look at Python based approaches, including Python Flask approaches. And then maybe we have legacy systems, which also we try to kind of provide a wrapper and interface it so that we can still continue to access it from these new front ends. And API services using Node.js, Express, Mongo kind of approaches, which are more contemporary and more focused on distributed systems, unstructured data. And then front ends looking at like Angular, React.js, React Native, based on the kind of requirements where we are serving mobile applications or it is web-based applications, kind of progressive web applications, whichever being the context. So these are some of the directions moving into distributed systems. And one of the main concrete inputs for architects is a reference architecture. Sometimes we go with existing architectures as a starting point for reference architecture, and we also try to look at the contemporary architectures. Here is one example which has been done by Microsoft, which is called eShop on containers, which is a kind of good reference architecture, looking at it from a retail e-business shop e-commerce shop perspective. So here you will see the organization in terms of catalog, ordering, basket, marketing, locations, and identity, and kind of event based kind of an approaches, which is more towards event driven direction. And you have API gateways, which will kind of tune it to the client applications you are looking at, and Docker based, container based mechanisms, which provide us the capability to more take care of dependencies in a more containment fashion. So then here we are talking about mostly no data shared, self-contained, over a message queue, like IPC talking each other or an event-based, domain-driven, and single responsibility kind of an approach. So one of the best examples are sometimes described in this book, Reactive Microservice Architecture Design Principles of Distributed Systems, John Arbonner. And this is, I think, from a basic reference architecture, provides architects with a very important angle, which is supported by code, a jump start, you can say, to build your architectures. So that is one of the most powerful ways to start uh, creating software architectures. And then let us not forget the other factors like an ecosystem where the infrastructure is easily becoming more and more significant. Like you'll see a test driven approach using Postman for testing API services, JMeter for performance analysis, probably, and Jenkins for pipeline approaches to continuous integration, technology stacks, containers and hosting providers. All this plays a very important role in today's system. And again, our infrastructure and the kind of preparations that we make around infrastructure make us continuously improve and evolve as we go. Whereas without these steps, we will struggle to make a faster movement. So speed wise, this infrastructure plays a very important role, and probably the initial preparation should, most of the architecture should have an element considering the ecosystem and the factors around it as a principle, as a direction. So in short, when we look at it, we are with the new contemporary architectures, we are more looking at business agility as the objective, and dependency management and technical depth should be in control so that we can continuously evolve faster in the forward direction, and ability to make changes, which is probably something so that the dependency is contained in a more single responsibility angles, and how the dependencies are um, more structured, more organized as smaller elements, granular elements, and end-to-end infrastructure support plays a very important role. And obviously, the biggest, the most useful starting point for any great architecture is a good reference architect. Thank you.